Hey everybody and welcome. Today is Thursday, March 9th, 2023. This is the next edition of the KCP-Edge community meeting. Welcome to all. Just going to go ahead and there is a link to the Google Doc agenda, which is new for these meetings. It's listed in the chat. If you're attending, and I would like it if you, it'd be great if you could record your attendance in that Google Doc. If you are having trouble reaching that Google Doc, go to KCP-Dev Google Groups and register with that, and you should have access to the document subsequently. I'm going to go ahead and share out. So today's agenda is quite packed, so we'll get right into it. This is the issue that's associated with it, and the link to the new agenda is located here. So please use that, and I'll be using this note as well. So if you would like to join along, please click on the link in the chat. Is there anybody who doesn't have a link to the agenda in the chat? All right, great. Thank you. Okay, so let's get started. Let me read off. So here we have a contributor code of conduct. As contributors and maintainers in the CNCF community and in the interest of fostering an open and welcoming community, we pledge to respect all people who contribute to reporting issues, posting feature requests, updating documentation, submitting pull requests or patches, and other activities. We are committed to making participation in the CNCF community a harassment-free experience for everyone, regardless of level of experience, gender identity and expression, sexual orientation, disability, personal appearance, body size, race, ethnicity, age, religion, or nationality. Basically, just be nice to everybody, please, while you're working in the community. Appreciate that. All right. So in the agenda today, we have a few things lined up. We'll start off with, if you are looking to nominate anything as a topic to discuss today, please insert it here. Wanted to let everybody know that we've done some work in terms of getting good first issues and help wanted items out and about. You could go to the /contribute off of our repo. You'll see there are items there that you can pick up and work on. This is a static URL that GitHub makes available for all repositories and searches to find and lists good first issues in it. So there are some new ones in here, such as making a new make target for deploying and configuring KCP and KCP-Edge components, creating a short video with no audio that walks through the steps of the quick start, and of course, a quick start in general. And then there's some more involved issues there about creating behavioral unit tests and implementing the where resolver in our placement translator. So there's just a variety of different levels of contribution that you can make, and I encourage you all to step forward and see if you would like to just simply put your name in the issue associated with those items, and we'll go ahead and look to see if we can assign it to you. So thank you very much for your participation and contribution in advance. Our new agenda is located here as I'm reading it off. That's a new development for this specific meeting. We have a list of tasks and for the Q1 POC that we're working on. It's located at the document enclosed. You can look at that there. You also have access to this if you join the KCP Dev Google group. The list has associated assignees at this moment. If you've joined and you would like to work on something, I'm more than welcome to help and put you as an assignee there, or just ask a question in the margin as Google Docs provides a facility to do so. And I want to say congratulations to June Dwan, a member of the community. Thank you very much for putting in a CFP for a GitOpsCon talk, a quantitative study on Argo CD scalability. The talk was accepted, and we will be presenting it. The schedule is yet to come out. I believe it's either on May 8th or May 9th, and we'll be scheduling some travel to go there. That talk has not only spurred an acceptance from GitOpsCon on its first try, which I should say is an incredible feat, because I know many people who try and don't succeed. But also, it's also led to other opportunities where we've been asked to and invited to work with the Argo CD community, just as recently as this week, to work on scalability concerns with them and do benchmarking tests. So I'm really happy and pleased. There's also an associated blog that's on Medium that I believe at this point in time has had over 3,500 views. And a lot of those folks are in the DevOps and DevOps-ish community. It's really attracting a lot of attention. So if you haven't seen it already, go out to kcp-edge.medium.com and check out our reading list. And you can see there are other items that you can read up on, including June Duan's post. I've already gone over some of the calls for help that we have that are out there in the /contribute. One in particular that is of high importance and priority at this point is a quick start guide, issue number 207, and a short video, issue number 208, and a new make target for deploying and configuring KCP and KCP-Edge components automatically in 212. Those are low-hanging fruit, good first issues for all types and varieties of skill sets. There are also some more intricate ones that are there for things like placement translator, internal interfaces, the where of the interface that Mike Spreitzer will talk about next on the agenda. So that's all I had for opening remarks. Apologize it was so lengthy, but there's a lot of new developments. Is anybody else that is out there that would like to, that has anything that would like to put on the agenda, please amend it now. Any questions for me? I don't see any hands risen. Yeah, please raise your hand if you have questions. Great, and please remember to mark your attendance accordingly here, if you can. Okay, so let's move on. Mike, you're up first with the placement translator interface.
Okay, internal interfaces. Yeah, how much time should I aim to spend here?
Mike, if we can box it for 10 minutes, that would be great.
Okay, let me aim for that. All right, so it is basically 10:09.
There's a lot of people out there watching the recordings nowadays. We're getting
Uh-huh.
a lot of good hits there. So if you need
Yes.
more than that, then please feel free. It's an important subject.
Well, I think so let me put it a different way then. How detailed do I'm trying to figure out, how detailed I want to be here. Um, so
Yeah,
in
we
10
can
minutes
see
I
your
can't,
screen.
yeah, I can't be terribly detailed. So all right. Let me make it a little bit bigger for ease of consumption. And oh, wrong. Sorry, just a minute. Yeah, okay. I want this one. Okay. All right. So I'm going to just kind of zoom through kind of the big picture here since I don't think we won't have time to go through in any detail. In fact, in our previous meeting, I started to go into detail and ran out of time anyway. So that's just the way it's going to have to be. Okay. So I started drafting internal interfaces for the placement translator. I call it that because it basically translates an edge placement problem or edge placement problem. Well, each edge placement uh, uh, problem into a collection of TMC placement problems. Um, and the so part of handling an edge placement is done by the scheduler, which resolves the where predicate into a resolved where. That is to say, a collection of single placements. The rest of it is in here. Um, so there are 5 pieces in here currently. I'm thinking probably the last 2 should be merged. But the first piece imports the results of the scheduler and makes it available in internal interfaces. So that monitors the result, the work, the results coming out of the scheduler, um, which are called here. Well, yeah, so I created interfaces. So the idea here is one process going to have some major pieces. Um, I debated whether they should interact through a defined shared data structure or Go language interfaces. I settled on the latter because I think it's going to make for more independent development. And the goal here, the main goal is to break this relatively big process down into smaller pieces that can have people working on it independently. So that's why I went with Golang interfaces. Um, and again, this is just a draft. We can revise it as we want and need. And I'm not entirely happy with it. One of the things I'm dissatisfied about right now is the where resolver interface kind of expresses only part of the functionality. It says what comes out of the where resolver. Doesn't say anything about what's going into it. So it's leaving that implicit. Same for the what resolver. So these two things make available to the rest of this process the results of hand resolving each of the two predicates in an edge binding, the what predicate and the where predicate. Then so each of those a resolved what is a set of workload items. A resolved where is a set of single placements. Then there's the so-called set binder that is given these given these sets and pairs them up and resolves. There's the potential for workload conflicts. That's now, I think the PR for that is now merged into the description of the outline. So if you look in the outline, you'll see a discussion of how to handle of what workload conflicts are and how they're handled. The set binder sort of reorganizes and resolves those conflicts and presents the result of all that in easily digestible pieces to the workload projector and placement projector, which are really given information organized in a way that I think is natural for a syncer to consume. So that's kind of the top level idea here. Let me stop and ask for questions, see if that's making sense.
If you have a question, please raise your hand. Mike, I have a question.
Go.
So Mike, I just put in the chat for other people's references the diagram that this work is associated with. So I just wanted to let you know that other people can follow along with that diagram if they'd like to. That's all. Thank you.
Okay. 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 Any other questions so far or comments? All right. So the next thing to say about this is I did try to pay some attention to designing these interfaces to not require to enable relatively efficient interaction amongst these pieces. So they're designed towards and with an eye towards not requiring more duplication of data structures than necessary, but I think they will require some duplication of data structures, and we can maybe address that later or switch to a shared data structure after things are more worked out. But the priority here is to get something functional first. But I paid some attention to that. So that's why you'll see kind of a lot of provider consumer or provider client or producer consumer kind of pattern here. And the idea is that the producer or provider holds the primary data structure or the data structures it needs to provide information, and then the consumer is given information in pieces that are meaningful to the consumer or receiver. Another thing about this is, this is going to all be driven by controllers, really internal controllers that are built according to the usual pattern. So there will be informers, work queue, and workers that pull object references off the work queue and then drive stuff into the rest of the process. So there's going to be a lot of concurrency here. And when you've got independent object or components interacting with concurrency, they're going to be mutexes, and you have to make sure to not get into deadlocks. And the usual way to do that is to establish a partial order amongst the mutexes. So there's an outline here about that. The idea here is, there is a partial order. So what that means is when component A or mutex A precedes component or mutex B in the partial order, what that means is it's okay for A to hold a lock while trying to acquire the B lock, but not the other way around. Okay, let me stop there and ask for more comments and questions.
So Mike, more generally speaking, just from my clarification, what you're looking at here overall, the placement translator is responsible for taking the what and the where and combining them in a way that a workload can be then delivered to the appropriate mailbox. Is that generally speaking what's taking place?
It includes getting the workload into the mailbox workspace.
Okay, great. Thank you for the clarification.
Okay.
Mike, another clarification question.
Yes.
In the future, the goal is to have the HMC syncer on the edge rather than the DMC syncer, right?
Yes, there's a roadmap here that is not yet clearly described in the outline, and I want to add that. And At first, we are going to use the TMC syncer between the mailbox workspace and the edge cluster, and later we'll have our own syncer, and they will behave differently. Right? The TMC syncer, what it does is it just runs containers in the edge cluster, but they're connected back to the mailbox workspace API server. And that will not give us what we want, which is self-sufficient edge clusters. So, and as you well know, and I'll just reiterate for everybody else's benefit, right? Ezra is taking the lead on working on the edge syncer, which is going to behave differently than the TMC syncer, and it will produce self-sufficient edge clusters where the containers are not connected back to the mailbox workspace, rather they're connected to the API server in the edge cluster.
I wasn't going to go into those details. I just want to make sure or understand from you, do you think that when switching to the edge syncer, the API you are now presenting will not be impacted and stay the same, right?
Well, right now what I'm presenting is not an API, it's internal interfaces between components in one process. I think what is shown here can stay the same. Obviously, there are differences. So, for example, one of the difference is that in the earlier milestone, when copying workload from the workload management workspace to the mailbox workspace, this step has to denature the objects because TMC does not denature. But later, the TMC syncer will do the denaturing, and that copying from the workload management workspace to the mailbox workspace will leave denatured objects denatured.
Okay, thank you, Mike.
Okay. All right.
Good information, Mike. Thank you. Yeah, continue.
Bob.
Bob?
I'm sorry. Since I'm new to Go, so I just have a quick question about the locking mechanisms. Is this something that you're saying should be a coding convention that we adhere to, or is this something that's built into Go in terms of this precedence of locking to avoid deadlocks?
Yeah, it's not right. The possibility of deadlocks is built into Go. This way of avoiding them is not. This is actually a pretty interesting issue in programming in general. This is a coding convention. This language, and I'm not aware of any language that helps developers solve this problem of imposing on themselves and following this discipline of imposing a partial order on the locks.
Is there any intention to have a sort of a monitor thread on the locks to be able to walk down the chain of all the locks to see whether there's anything that's broken? To see if there are deadlocks.
I'm not aware of a way to write that as a in Go. What Go does provide is a debug endpoints, and this process, like most processes, should expose debug endpoints. And there is a debug endpoint that lets you, for example, get a dump of all the stack traces, and that's what you would do to debug a deadlock, should you think you have one on hand. The issue of how to debug deadlocks is an interesting one, but probably not appropriate to go into in depth here.
Okay, thanks a lot. Thanks for the clarification.
Okay. All right. So the particular locking order chosen here is, again, based on that outline I mentioned earlier, that the things that there are some components drive other components. So the choice is that the driving component precedes the driven component in the locking order. That enables simple synchronous calls. The driving component can call into the driven component, and the driven component can just do its work synchronously right in that call. The alternative, and you might find the alternative more natural in some sense. The driven components are higher level, but if the order were reversed, then any callbacks, and since this is all dynamic, there would be callbacks to inform the higher level component of changes. And if we did the locking order in the other order, then every callback would involve a fork of a go routine to handle the being notified of a change, and it would all get more complicated. So that's why this particular locking order in here is chosen. The next thing to say then is I found myself doing this producer-consumer pattern or provider pattern over and over again. So I actually tried to write it down or abstract it into some generic types. So I defined this thing called a dynamic map provider, which is a thing that provides the service of a map whose contents change over time. It's generic. The key type and the value type are type parameters here. And it's got two methods. There's an add receiver. So that's something that basically a client of this will call add receiver, saying, yes, I want to be notified of changes to the map and potentially the current contents when adding the receiver. And there's also a get method, whose signature is maybe a little surprising here. Normally you would expect get to be given a key and return a value. But for a component B that is later in the locking order, that's a problem, because by the time I don't have should go into in detail. So this is deliberately written this way to facilitate coding with that particular locking order that we talked about. So the way get works is the caller of get passes a callback that will be given the value. And so the provider takes its lock, calls the callback while holding its lock, so that there's less confusion than you would get the other way otherwise. And since we're again running a little time, I'm just going to again zoom through these very briefly. So the five main types are the where resolver. Okay, that provides a dynamic map from an external name for an edge placement object to the resolved where, which is basically a set of single placements. The what resolver is a dynamic map provider from, again, an external name for edge placement to a set of workload parts. The set binder then is given something that can be given those two sets. And in fact, again, I use this mapping receiver abstraction here. But I want it to be two different mapping receivers because it's receiving two different ones. You can't have one method or two methods with the same name but different signatures. So that's why there's just these things that reveal the two behaviors. And then it's the job that it ultimately does is it's given these two sets, and then these two these two dynamic maps. It's kept appraised of these two dynamic maps, and then it reorganizes and solves the workload conflicts and presents the resolution of all that through this type or this interface. It implements this interface, which is about providing that information. The workload projector then is a client of this, and the placement projector as well. The workload projector is the thing that copies with customization as appropriate once we get to that point in the roadmap, from the workload management workspace to the mailbox workspaces. The placement projector is the thing that takes the edge placement objects and translates them into TMC placement objects. And I'm thinking probably these two should actually be combined because the distinction is really lower level. Both of these are, in some sense, the workload projector is about dealing with all the objects found in the workload management workspace, one of which, or some of which, is going to be the edge placement objects. So it's maybe a little bit more natural to bury this job inside this job. So I'm thinking of making that reorganization here. And I think, again, I'm just going to invite people to look, here for more details. And as I said, we're looking to get people signed up to implement the pieces. So I'll stop there here, Andy.
Mike, this is excellent. I mean, it really shows a lot of progress. I'm really excited to see what you've done so far. Mike is really putting on a masterclass here, and I'm really appreciative of all the time that he's been spending on these. Mike, I put in the chat next to, if anybody's looking for linkages to the code that Mike just went through, or a diagram that shows the high-level proof of concept. we'll have hopefully in the next day or so that proof of concept will start to shape into a larger example that we'll be posting out on the doc site as well. I'm just dropping a link here now. And to promote Mike's work, we just had a premiere video drop on YouTube this morning, which takes you through this and other areas that Mike is exploring along with the rest of the community. You're welcome to view it now. And he's also got a Medium blog post that's available out on medium.com, and that is an expose of what he's working on as well. So 7 ways to stub your toes on the edge. So if you haven't already read it, please, I encourage you to do so.
So
All right.
Eddie, let me also just add regarding this POC. In the Git repo, you can also find an outline of the POC and an example walkthrough. All these are works in progress, but intended to give a little more broader understanding of the POC.
Thanks, Mike. This is excellent. Thank you so much. All right, next on the agenda, we and all these links also are in the agenda as well if you need to go back and revisit them later. Next up, we have June. Let's talk a little bit about the work and the progress he's doing in the community on Edge Scheduler. June?
Yeah, sure. The Edge Scheduler is an extension of the TMC scheduler. In this particular POC, the role of the Edge Scheduler is to partially solve the where problem by evaluating the where part of the edge placement, as well as listening to what's happening on the locations and sync targets, and then synthesize them to generate the output to be consumed by placement translator. The Edge Scheduler is currently under active development. It's changing pretty much every day, but we do have a runnable version in the in the main branch as a general principle. It's always runnable, and we also have a short piece of documentation to instruct anyone who is interested to run it through. So I encourage people to try it out and give us any feedback if there are any.
Thanks, June. Hey, June, could you, in the chat, could you drop, I put the edge placement Go file in there, the code, but if you have a link to the PR, the issue number that you're working on, would you please give that to the audience?
So do you want the code itself, or do you want the instructions to try out the code?
Whichever you have links to, whichever you think would be helpful to the community to have. Remember, people
Okay.
that are watching the playback, it'll give them a way to look at what you're working on.
Okay, I'll put a link there.
Thank you.
Yeah.
Okay. Anything else, June? Any questions for June? All right, let's move on. Next up on the agenda, we have Braulio. He's got a couple of items that he wants to talk about the dev environment that we're creating. So it's a way to automate a dev environment for ourselves and others to actually use as a platform to build the next evolution of KCP-Edge componentry. And also a little bit about metrics, definition, and collection with Prometheus and Grafana. Braulio, please take the floor.
Thank you, Andy. So for the dev test environment, so our goal is to have a quick install and that can be deployed easily of our KCP-Edge that can be running even in your laptop machine. So to achieve that, so we are exploring using the KCP Playground tool that is being developed in the KCP community by Fabrizio. So this tool allows you to deploy KCP and starts KCP classes, use kind classes, as well as creating resources and namespaces. So we want to use Argo to use that tool, which is just to bootstrap the KCP components that we need for Edge AMC, and then on top of that, deploy the components that are specific for Edge AMC per se. Let me just quickly share my screen. Okay, so on the Edge AMC repo, so we have a lot of stage scenarios to how you can deploy the Edge AMC components piece by piece with this scenario developed by Mike. So, and I'm going through these scenarios examples and trying to deploy the common components that are already available for Edge AMC via the KCP playground per se. So the next item in agenda is that we are building an environment that we want to deploy with our KCP-Edge component at scale. So to do that, so this is the design of the architecture that so we are going to explore. So we just deploying on the AWS. We are going to have the core region where we're going to deploy the KCP and the KCP-Edge components, and then we have the center that the edge region where we're going to just deploy in small VMs that's going to be running kind of Kubernetes cluster, and we are going to put them behind a NAT because the edge device the user don't have direct access to the internet. And we are going to be using collecting telemetry. So for telemetry, we are going to be using Prometheus, Grafana, and Node Exporter. And we have building our automation to deploy Prometheus and Grafana and Node Exporter to run in the center, and as well as to run Prometheus on the edge using the Prometheus agent. And we may come up with this design also with the help from Sergius from the KCP community. So we have the automation already to configure Prometheus on the P clusters as an agent, and to remote write the data to put the Prometheus server in the center. So yeah, please I'll invite everyone to test the code, and try out, give comments, and let us know if you run into any issues. Yeah, that's all. Thank you, Andy.
Hey, thanks a lot, Braulio. That's fantastic. I put links in there for the example that you gave for the for monitoring. I'm sorry, not for monitoring, for the dev environment. And I put a link in there also for the monitoring discussion. And they're also in the agenda as well. Thank you. All right. Next up, I wanted to just give everybody an idea of what we were doing for demonstrations, actually a demonstrable workload. So we've got a product that IBM acquired a while back called Maximo Application Suite. It's one of the components in there is called Maximo Visual Inspection. This is used in the industry for visually inspecting let's say items that are out there in the wild, using AI models to train them at first, then use them for inferencing at the edge. And so you can use this with a standard iPhone. There's also the capability to do this with another device, let's say an RPI, something a little bit beefier like a Jetson Nano or an AGX, something of that nature. So we've been doing some experimentation around this. Franco Stellari, who's a community member here, has been working on transitioning a demo that we had done in-house to something that can be exposed in the community for use with KCP-Edge, or initially with KCP, and then to drive the discussions and conversations that are necessary to expose the gaps that exist between where KCP-Edge's goals are and where KCP ends. And so I'd like, Franco, could you give us an update as to the resources that you're trying to deploy and maybe how that's exposed some of the gaps? We'd really appreciate that here.
Okay, sure. I'll let me show my screen briefly. So the Maximum Visual Inspection tool is a deployment that we used for a previous POC using our Edge technology KIST. So I'm trying to look in this table at the resources, at the object that needs to be transferred from the center to the edge in order to deploy this application. First, we have a group of secrets that are necessary to access the images of the application. Some are specific to the MVI application, and some are specific to the operator that are used for the deployment. We also have some secrets or credentials that are required for the Edge MVI application to connect back to the MVI hub. Then we have two groups of resources that are needed. First, we go through a process where we deploy an operator that will pull the MVI app and set it up on the Edge cluster. That the resources are listed here. In particular, we have modified the YAML and deployment to run all in the same namespace. Some resources are cluster level, like the cluster level role binding and cluster level roles. Once the application is deployed, then we run a second operator that will configure the Edge application and customize it to the specific needs. And the resources that you can see here are very similar to the previous one. So.
Thank you, Franco. So I have a question here. So Franco, have you determined that there are any gaps between right now that the KCP syncer is going to give us some initial challenges, and then what we might need, and then why that might be necessary for us to have a syncer that's specific to Edge locations and concerns?
So the standard syncer will not currently transfer several of these objects, including specifically the cluster roles. It is mostly designed to transfer the deployment, but most of the other objects need to require a custom syncer basically to be deployed.
So again, to be clear, in the roadmap for this POC, we have two stages that are called out that will both work for this in different ways. In the first stage, we use the TMC syncer between the mailbox workspace and the Edge cluster, and that gives up on self-sufficient Edge clusters, but it works for arbitrary resources because the mailbox workspace can hold arbitrary resources. And in the later stage, we have our own syncer that will produce self-sufficient Edge clusters and will propagate the necessary resources. The other side of the issue here is what's the source? You don't want to be checking secrets into Git. So there's a conversation to be had about the proper structure for feeding into this. The primary architecture in this POC takes as a starting point in the sort of north to south path. The central part says something puts the right workload prescription into the workload management workspaces without being overly prescriptive of what.
Okay, so let's take a look at just maybe we can point out where that is in. Let's see if I can bring it up here. Okay, here we go. So let's share this out. I don't know that the larger community has seen this yet, so maybe it's worth explaining where we are in this diagram. Might have been something we could have done up front, but I think where we're talking about the MVI Edge itself is being deployed or down at the Edge P cluster. So the TMC syncer right now, we're dealing with some limitations there, and of course exposing those gaps and working on trying to shore those up with augmentation in the future, as Mike puts it in the roadmap. And those include things that are cluster role specific that do not allow us to transmit those across this architecture currently because of those limitations. Mike talked a little bit before about the placement translator. That's up in here. And this is in the Edge Service Provider workspace where this is, Mike, if you could talk a little bit about API export and bindings maybe, and how those interoperate with these units.
Sure. Very briefly. So as I've been saying before, and you can kind of see this picture. There's a left-right divide here. There's inventory management on the left, and the rest is workload management on the right. So we suppose there's an API export from the inventory side of the APIs for inventory, which we're reusing and somewhat abusing the location and sync target object types from TMC. So there are API exports. We assume there's an API export somewhere for that. And then the Edge Service Provider workspace has an API export for the Edge API. We put currently all the Edge APIs in one API group. So there's one API export of that API group that has the object types for the Edge MC APIs. The workload management workspace, each one of those needs to have an API binding to the Edge API export and any relevant API exports for defining the actual workload prescription, such as, for example, if it want to use regular Kubernetes objects, it has to have an API binding for Kubernetes API, some Kubernetes API export. Now in KCP, it happens currently that I think if you make a so-called universal type of workspace, you'll get such a binding by default. But in general, in KCP, there are different types of workspace. They don't all have that binding by default. So the general story is that whatever type of workspace you choose to use in making your workload management workspace, it needs to, one way or another, have that API binding or bindings in it for defining the workload object types that you want to use.
Thanks, Mike. And maybe you've alluded a lot to the roadmap. So I'm showing here the where the different stages are elaborated and detailed.
No, that's not actually the roadmap, though.
Oh, okay.
So that is, so the roadmap that I was talking about is stages of development in terms of, or growth in terms of functionality or scope of function. So, we've talked earlier about we want to be able to have some milestone where we can have some end-to-end exercise and show some demos, but we give up on self-sufficient edge clusters. We felt that was the fastest way to get to a working end-to-end interesting demo. But we want to repair that. So later in the roadmap, and again, this roadmap is not written down. I want to do a PR ASAP to add that to the outline, explicit roadmap. Later in the roadmap, we will add using a different syncer. So currently, the drawing you showed says use the TMC syncer, but we've been discussing ways in which it doesn't do exactly what we need. Ezra's working on producing a syncer that does what we need so that we can get self-sufficient edge clusters. So that will be later in the roadmap. Other things that are staged out is we're going to start off without worrying about customization or summarization. We want to bring those things in later as well. So those are the issues for road mapping.
Okay. All right. And this staged approach that you have in this document that I missed.
No, those are just stages of running through one
scenario.
Right. So maybe you should call them steps or mega steps or step groups. Okay. It's just an organization of one script, one run through at one point in time.
One scenario. Okay.
Right.
Good. Yeah, this is very helpful. So all right. So we've reached, I believe we've reached the end of our agenda. I'm going back to look. Is there anybody else who has any other topics they'd like to discuss? It's a little late in the call to do a triage, so I'd like to give time back if possible. Or any folks that are new on the call that have any questions, would like to introduce themselves? Okay. All right. There's a wealth of information in the chat here. It's been mostly captured. The demonstration that was being presented by Franco, about MVI, KCP-Edge. It will be available for public viewing, we hope, by KubeCon, and that'll be held in Europe, in Amsterdam, the Netherlands, between April 18th and the 21st, at a portal experience in our IBM booth. So we're still preparing that. We'd love to see you there. So stay tuned. Anything anybody else would like to offer the community before we close the call? All right, thanks everybody. Enjoy the rest of your week, and we look forward to seeing you at our next call on February 28th.
Thanks.
Bye-bye.
You.